In this video, we're going to consider this problem, which is similar in nature to the one that we did at the end of the previous video in this series, just ever so slightly more complicated. So in this question, we're going to take the bounded region not between a function and the x-axis, but between two distinct functions, f of x equals x minus 1 squared plus 1, and g of x equals 2. Now before I even continue, before I even go on, I'm going to go ahead and get a nice little picture of these functions going. F of x, quadratic function, opening up, vertex at the point 1, 1, and we have our constant function g of x equals 2 coming up here at the top of the region. Now I'm going to take the bounded region between these two functions, and I'm going to spin this region around the x-axis to form a solid of revolution. Now I'm going to do my best here to get a reasonably nice drawing going. Let me try hard. So if I spin the green line around, it'll create a cylindrical shape. Let's do our best. Get a shape formed here. And we have some dashed lines in the back to give us a sense of depth. And then if we spin the gray line around, let's say here, this will come down in, something like this. Give us a nice smaller portion cut out of the larger portion. And so a nice arbitrary cross section would look a bit like this one. I want to try and get this nice graph going here. Would look a bit like this region stuck in between the outer cylindrical portion and the inner sort of tubey portion. That is our region that we're trying to find the volume of. Okay, so having done this, let's take a closer look at this nice slice here at some x value. So let's call this a of x. Let's try and find the area of the slice at this x value. Now this slice has the form of a disk with a smaller disk cut out of the center. And to find the area of such a thing, we would need to find pi times the outer radius squared minus the inner radius squared. Outer radius I will call big R, little radius I will call little r. Now notice that the big radius of any one of these disk-shaped cross regions, is equal to 2, is equal to the output of this top function. So this would be pi times g of x, quantity squared. And then I would remove the squared radius of what is in this case the y value of the innermost function, the y value of the bottom function f of x, minus f of x, quantity squared, is the lower radius. And that will give me the area of this punctured disk, of this washer-shaped cross-section of the region. So let's go ahead, let's remind ourselves who is f of x, who is g of x, and let's go ahead and calculate that interval. So we have g of x, who is 2, so 2 squared being 4, and then we'll take away f of x, that's minus 1, pardon me, x minus 1, quantity squared, plus 1 on the outside, square that, and that is the area of any particular washer-shaped cross-section I take of this volume of revolution. So to finish this problem, all that you would need to do is integrate from the starting and the final x values, limits of integration for this region, of this difference pi, outer radius squared, minus inner radius squared. Now once again the question becomes, what are the appropriate limits of integration for this region? In other words, where does this figure stop and start? And the thing that I notice is that this region starts and stops where the horizontal line, g of x, and the curved parabola, h of x, intersect. So to find where these two intersect, I can set these functions equal to each other. X minus 1 squared plus 1, where does that output equal to? So x minus 1 squared equals 1. Taking the positive and negative square root, we arrive at two possibilities. X could be 0 or x could be 2. And therefore, to find the volume, we would only have to integrate from 0 to 2 pi, 4 minus x minus 1 squared plus 1 squared dx. And that integral of pi large radius minus small radius squared will get you the result for this problem. I will leave the rest of this to you as an exercise, since this is just a polynomial and we've integrated many such polynomials before. But in the next video, we'll give a general formula that summarizes the process that we did to find the volumes of all manners of solids of revolutions that are obtained by spinning regions around the x-axis.